This next panel, I'm also going to be up here hosting this one as well, will be focused on supporting critical operations. I'd like to welcome to the stage Daryl Haegley, Technical Director for Control Systems, Cyber Resilience, and Cyber Resilience Office for Control Systems in the Department of the Air Force and U.S. Space Force. Ahmed Ali, COO for National Security and Defense Group at Google Public Sector, and Jennifer Krischer, VP of Defense Intelligence at GDIT. Let's give them a warm welcome. Alrighty, welcome everybody.
Hello.
Hello.
Morning.
Ben, I think, set us up for great success for the day with a good foundation, understanding what the edge is. But I want to take it a bit further. You know, when we think about critical operations, as we look to sort of unpack that within this panel, I want to understand what that means at the edge, what those are, and how evolving technologies in particular are in enabling those in a more efficient and effective way. So again, welcome. And Jennifer, how about I throw it your way to start with?
Sure, thank you, Billy. So when I think about the edge, I think about it from a military perspective. I have 25 years as an Air Force intelligence officer, so that's where my mind immediately goes, is those days when I was, the lone intel officer in Kenya supporting operations in Somalia. It's what technology do you need to get the mission done? What's the bare minimum? And then what do you need more to be successful, to be meeting that challenge? And so in today's environment, I think a lot about the data that is necessary at the edge. You have to make sure you're getting the right data to the right people at the right time. You don't need all of the data at the edge, just the right amount of data. And so that's kind of what I'm thinking about when I think about the evolving technologies. And really, it has to be focused on that data.
I think that's a great point, the right data at the right time. It doesn't have to be all of the data.
Yeah, absolutely.
It's a very, very smart point. Ahmed, I'd love to hear your perspective, how Google's focusing on the edge, but also when you think of the edge, what does that mean in your background?
So this has been a little bit of a journey for Google, because we have typically thought of the edge as anything that's not Google. Like that's a little bit of a, maybe a conceited way to look at the world. But in reality, the thing that we focus on the edge is traditionally when you talk about pushing capability to the edge, the primary reason is survivability, resilience, like what happens if I'm not connected back to the headquarters or the centralized locations. We're actually starting to think about it way differently, which is like not so much about resilience, just that, but also about opportunity cost. So in other words, like everything that we try to do, when we interact with consumers on the internet and that kind of thing, we literally have like a couple of seconds in order to give that user a fantastic experience, or they're going to go somewhere else. So for us, pushing capability to the edge is about doing the things that we need to do in order to get people to use the services and to not miss out on those opportunities. The other thing that we think about at the edge is like now that there is these capabilities, which is your smartphone is essentially a supercomputer in your pocket compared to kind of like what would be considered a supercomputer in the 1970s. It offers so many different abilities with all of cameras and AI doing computer vision reading and all that kind of stuff to actually cross that last digital gap that has existed with other things that are at the edge. So in other words, I don't need to network a machine at the edge, but if I have a phone that can take a picture of it, I can actually push intelligence across what is essentially an air gap. And so we're very interested in delivering those kinds of capabilities.
Daryl, Air Force, Space Force, I think we think of those as certain edges, but I think there's a lot more that people might not see as part of the portfolio of what the Air Force does and the Space Force does. So talk to me about your role and also what you think of as the edge and how technology plays a role.
Yeah, certainly. So yeah, military operations have always been pointy end of the spear, always that first contact. And then, we've evolved over being able to do things at range and from far behind. We've now talked about a contested homeland that we know that the adversaries are trying to get into where we're at right now, and that we also launch operations militarily from the homeland. Space operations, a ground station, they're here, not necessarily always forward deployed. We also have to get things logistically from one end of the United States to another before that gets forward deployed. And we want to be able to manufacture or get things communicated at that forward edge. What's great is that over the last several years, especially in the operational technology space, there is technological advances to really enable a lot of this connectivity that Bennett opens up with. Hey, these things aren't designed for this, and they're not communicating that way. Now there are many options to enable that.
Yeah, I think it's often, or maybe this is just myself speaking for myself, but it can be lost on people how much that a U.S. military branch might be almost like a self-sustaining large city or nation, especially on those homeland installations, as you mentioned. So there's a lot that goes into it. There's energy systems, there's different facilities and things like that I know you spend a lot of time on in focusing on resilience. So let's talk about that resilience a bit. These are operations, controls, or systems that if they go offline, there's major consequences. So how are organizations like the Air Force and Space Force and others thinking about building resilience into some of those platforms?
Well, great news is a lot of engineers have built a lot of resilience into these devices to kind of fail in safe modes. So that's good. However, as we are connecting these and are trying to get some of the data from these, that sometimes we can fool them or we can fool the operator to not really believe what they are seeing. That's one of the things I think that we need to practice in, is to understand in a contested homeland environment, the information that you're getting, is that the real information, and can you make decisions on that, right? So if you're getting ready to deploy the information about, there's a virus at the school, there's a plague at the hospital, there's something in the drinking water, and then you still have to go to deploy to make sure a weapon system gets deployed on a plane. So how are we practicing in that type of environment to understand what information we do need at the edge and be confident with that information?
Yeah, that's a great example. Ahmed, you talked to the customer experience kind of aspect of it, but how does resilience play into that? I imagine, if a system goes down or something goes down, that again affords poor user experience. It's not a good experience for that user or customer. Tell me about how you're thinking about resilience in your mission.
Yeah, so we think about resilience in two different ways. So the traditional way you think about resilience is like you're trying to prevent something disastrous from happening. We also think of resilience in another way, which is like, there's this fantastic movie from the 90s called Office Space where, the consultant is talking to this one guy and he's saying like, what would you say you do here? And so like if I ask someone, what would you say you do here? And they answer that, if they can't do that thing, that's what we consider an opportunity disaster, right? Because every organization in the government, in the private sector, has a specific mission in mind. I'm supposed to do this, and if I can't do that, then that's a big problem. So we think about resilience more from a traditional continuity of operations perspective and being able to continue to do the mission that you're doing. And so for us, thinking about resilience in that standpoint, we want to make sure that we can continue to serve users. That's kind of the formulation that we use when we describe that. The other thing that we think about when resilience is, and you can drive yourself insane doing this, is to think about like a dependency map, right? So you start thinking about like, hey, here's the thing that a user wants to do. That depends on this, and then these systems depend on that, and then that system depends on this, and like, you can go nuts trying to like go to like the 10th layer of dependency, so you have to draw a balance between that. But I'd say one of the things that often isn't done is we don't do enough dependency mapping and saying like, what needs to happen, especially when it comes to human support systems. So this is like, the ventilation in the room where a human operator is running, like that becomes part of the critical operation. So we think about it kind of expansively like that.
As someone who grew up in the 90s, you just made my day with the Office Space reference and weaving it into resilience at the edge. That's fantastic. Jennifer, I'm sure this is a huge part of your background, especially what GDIT is doing today. Tell me about that.
Sure. So when we think about resilience, we think about the ability to operate in a denied a distributed environment, the ability to continue to do mission when you can't connect to the interwebs, right? When you can't Google. You have to be able
And
to...
always Google.
Cannot. Sometimes, no, you can't. And so you have to be able to do your job. You have to be able to do your mission. So if you are, in a carrier group and you're in the middle of the, East China Sea, you have to be able to do your mission even if you can't connect, even if you aren't connected to Indo-PACOM headquarters in Hawaii or back to DIA to get the most recent data, but you have the data you need. And so having the ability to operate in not just one way, but several ways, that resilience, the ability to access the data, to have, again, just the data you need when you need it, and the ability to access different kinds of communication. So if you're used to only using satellite communications, you have the ability to access in a different mode or in a different modality. So building that iterative backup structure for accessing the data and having a certain amount that's there already. You don't have to reach back. You have what you need either on-prem or in the cloud, depending on the situation.
Well, I want to press on that a bit more because I think that data piece is so important,
Right.
and you've touched on it several times, so I'll come back to you briefly, but I'll let the other gentleman touch on it a bit as well. But when we focus on that data element, and we think about the kind of technology that underpins the ability to link those systems when there is that disconnect, what are those, and how important is it for that sort of construct to be built for edge missions where information transmission is critical?
Yeah, absolutely. So we look at it as a data mesh, right? So you have to have this ability of the data to be accessible in several different ways. And so a mesh enables you to access it from different perspectives and at different times, synchronicity, to be able to do what you need to do when you need to do it. Having joint regional edge nodes, having those edge nodes out there where the mission is, puts the data where the mission is so that you don't have a single point of failure. You have several points where you can access the data and you don't have to be super reliant on reaching back to headquarters where they might not have access to comms themselves.
I'm going to hop around. I'm going to go to Daryl this time. The data element, when you're thinking about resilience and making sure that that data transmission can still occur, how are you accounting for that? How are you building, that model as she's describing, a data mesh or other capabilities so that data transmission still occurs?
Right. Well, in the OT space, that may not be completely necessary. The HVAC system, if you disconnect the Ethernet cable to where you were getting consumption data, it will still operate. But we will not have insight that something might be making it out of balance or things like that. So you have to balance whether you still have that, try and get that connectivity, or that you have some kind of failover way. But what we're seeing is, especially from the OT operators, they are much more concerned about making sure that things still work, and that if something falls down or breaks, they get a spare and put it out there regardless of what kind of data you have.
Ahmed, same question. Data, how are you thinking about, when these systems are often in different environments disconnected, how can you overcome that gap?
That's actually a really good question. So this has been a little bit of a journey of transformation for Google, because traditionally our strategy has always been collect all the data, put it in one place, clean it, normalize it, and then run massive analytics on it at giant compute scale, and then intelligence happens and awesome things happen. So we have made the determination that as a fundamental strategy is just destined, you'll never keep up. Like, it's just not possible to collect all the data. Even us, we can't do that either, right? So we have started down the path of saying, if I'm trying to make sense of data, sensor data, that kind of thing, step one has traditionally been collect it and put it in a data lake or some kind of repository. We're actually going a little bit different and trying to create kind of these almost like an archipelago of islands of data. And then the key thing is to build an architecture where you can actually go interrogate all of them kind of live in stream. So rather than having to collect the data, you actually ask it, if you can provide enough intelligence to it, like something that has the data set, and just ask it what you need to ask it. And so the advent of, it started off with, called robotic process automation. Now it's turned into like agentic AI, but like that's the kind of the marketing buzzword for it. But ultimately the idea here is like you have the equivalent of a bunch of smart folks that are experts in each of these systems. They're all talking to each other, but instead of folks, those folks now are AI folks. And then that helps really kind of solve this problem of how do you avoid the need to have like constant big giant communications to push data all over the place.
Ahmed, I'm going to come back to you because one thing in speaking previously with you, you were a bit passionate about was this idea of being able to have organizations adaptable and able to scale up or down capabilities at the edge and the importance of that. So how are agencies or other organizations finding success in that? What's the key there?
Yeah, and so this is an interesting thing because like we had always thought of like the concept of edge versus centralized capability as a static concept. Like it's either centralized or I have to solve for like there's no connectivity. And so what we're actually seeing is like the real value is building systems that are adaptable and are able to like adapt to conditions, right? I have connectivity, great. I can make use of like the data mesh as was talked about before. I don't have connectivity, well, I don't need to have like completely denied or degraded or assume that I always never have enough connectivity, or I have different kinds of connectivity. I can talk to this system versus that system. And so the idea here is like to constantly have systems that have adaptable interfaces, adaptable modes that they can run in order to be able to take advantage, to deal with all kinds of different operational considerations and scenarios.
I want to close with a thought on cyber. Daryl, I'm going to come to you, and then I'm going to let Jennifer close it out. Cyber, as you're thinking about protecting these systems because they're increasingly targets from our adversaries, especially in the military sense, how do you inject that cybersecurity into this?
Yeah, so it's not so much a technical issue as almost like managing the psychology of change here, because are we going to have the OT people driving the cybersecurity requirements for OT, or should we have the cyber people driving those requirements? I'm reminded of a conference room where the thermostat was digitally reprogrammed to a microphone, and that information went back to China. Who's responsible for that system?
That's a very interesting example and also terrifying. Jennifer, close us out. Your thoughts on cyber and how it relates to this, this resilience at the edge and also protecting those edge capabilities.
Yeah, so cyber, is not just a monolithic thing. There's offensive cyber, there's defensive cyber, there's insider threat that you have to worry about, all of these different aspects of cyber. And so it's not a one-size-fits-all solution at the edge. You have to be able to adapt to where you are, and you also have to set up from the get-go kind of that zero trust. I know the next panel is zero trust, and I'm going to totally steal Dr. Salen's pitch here. But when you have the data and you have the identities of your individuals who are supposed to be accessing the information, knowing what data they can and can't access, that enables the zero trust environment that at the edge becomes paramount, because you can't have super clunky cyber environment. You can't have all of these things that are barriers to execution. You have to be adaptable. You have to be agile. And so that zero trust capability becomes paramount.
Well, as you said, that's a perfect segue into our next panel. But for now, Jennifer, Ahmed, Daryl, thank you so much for your time. Let's give them a round of applause.